quadratic equation, we know that x minus alpha into x minus beta will be equal to x squared minus alpha plus beta x plus alpha beta. Therefore, x minus alpha into x minus beta to x minus gamma will be equal to x squared minus alpha plus beta x plus alpha beta multiplied by x minus gamma. You got it there. Now let's expand. So we have x minus gamma. This one is x squared minus alpha plus beta x alpha beta. Now let's multiply. We have x cubed minus alpha plus beta x squared alpha beta x. Now we have minus gamma x squared. Here we have, because it will be plus, so we are going to have alpha gamma plus beta gamma x, and here will be minus alpha beta gamma minus alpha beta gamma. Now let's expand it. Let's write it out rather. Therefore, x minus alpha into x minus beta into x minus gamma will be equal to, we have this one x cubed. If you, these are the ones with x squared, so by the time you add the two, we are going to have minus alpha plus beta plus gamma into x squared. Now this one has x, you can see alpha gamma, beta gamma, alpha beta. So when we add that one, you can see sum of pairs. So this is plus alpha beta plus alpha gamma plus beta gamma x, please. So the last one, this is the only one that remains. That's the constant. Minus alpha beta gamma. Minus alpha beta gamma. You can see. Now let's compare it with this equation. If you look at it, we realize that b over a is equal to minus alpha plus beta plus gamma. That is what b over a is. So the sum of the roots, we can now see that minus b over a is equal to alpha plus beta plus gamma. So we can refer to this as sum of each. We use this one to represent each, all of them. That's why we put this sum there. So this means alpha plus beta plus gamma plus whatever. That's what it means. Now let's look at the coefficient of x. The coefficient of x here is c over a, and that will be equal to alpha beta plus alpha gamma plus beta gamma. I will refer to this as summation alpha beta. That is summation of pairs of the roots. Summation of pairs of the roots. That is what we have as c over a. Please take note of this. They are very useful for other calculations. Now look at it again. D over a is equal to minus alpha beta gamma. Therefore, minus d over a is equal to alpha beta gamma. That is the product of the three roots. And you can refer to this as alpha beta gamma. You can see. Please take note. And take note of the signs. I want you to make one observation also. Look at the sequence of the signs. Positive, negative, positive, negative. Take note of those things. Now, I also want to introduce you to another symbology in this root of quadratics and polynomial equations here again. Now, before we go on, I want you to note something. When we write S1, we mean summation alpha. That is summation of all the roots with power 1. When we say S2, we mean summation alpha squared. In this place, we mean squares of the root, sum of the squares of the root. That is alpha squared plus beta squared plus gamma squared, etc., depending on the degree of the equation. Here, what we mean is alpha plus beta plus gamma plus delta, So this makes it easy for us to do our representation or writing out the question in short form, shorthand form. So we have this to be alpha cube plus beta cube plus gamma cube plus delta cube plus like that, depending on the power. So you can also now let's talk about cubics. Cubics are of the degree 3. And if you look at cubics, you must look at it from like multiplication of linear equation with quadratic equation. Now, cubic is always in this form: ax cubed plus bx squared plus cx plus d equals 0. And then, for ease to handle, we always divide 2 by the coefficient of x cubed. So we always have it in this format: x cubed plus b over ax squared plus c over ax plus d over a equals 0. And then let us now say this as roots: alpha, beta, and gamma. And then the factors will be x minus alpha, x minus beta, and x minus gamma. You can see. So what are we trying to say? We are trying to say that this will be the product of this. That is x cubed plus b over ax x squared plus c over ax plus d over a will be equal to x minus alpha into x minus beta into x minus gamma. Now, let us expand this. Have x minus 1, that is summation of the reciprocal. So this place will mean 1 over alpha plus 1 over beta plus 1 over gamma plus we have s minus 2 summation 1 over alpha squared. This is another way of representing it. So we have 1 over alpha squared plus 1 over beta squared plus 1 over gamma squared plus we have s minus 3 alpha. Oh. So we have s minus 1, that is summation 1 over alpha, that is 1 over alpha plus 1 over beta plus 1 over gamma plus, depending, we have s minus 2 summation 1 over alpha squared, and that's going to be 1 over alpha squared plus 1 over beta squared plus 1 over gamma squared plus, we can also have s minus 3 1 over gamma cube. So this is another way of representing it. They are the same thing, but I just, so we can write it in short one like this for e. So we have 1 over alpha cube plus 1 over beta cube plus 1 over gamma cube, like that. So please take note of this. Now let's look at some other relationship we can get because of what we have done already. Now let's look at this. Yes, we have an expression ax cubed plus bx squared plus cx plus d equals to 0. That is how cubics are. We are now asked to, we are told that the roots are alpha, beta, and gamma. Find the expressions for s minus 1, s2, and s3. Now we have seen this expression. We know the relationship between all of this. Now, s minus 1 is equal to summation of 1 over alpha. Summation of 1 over alpha. And that is 1 over alpha plus 1 over beta plus 1 over gamma. And that will be equal to, let the LCM be alpha, beta, gamma. So this will be beta gamma plus alpha gamma plus alpha beta. And from our knowledge, we know that this is sum of pairs. And this is sum of 3. What is this one? This is going to be c over a. And this one is going to be minus d over a. Minus d over a. You know? So it's going to be, at the end of the day, you can write this one as either like this or minus c over d. Please don't forget this time. Minus is there. We are through with that one. Now we have to find s2. S2, which should be summation alpha squared. That is alpha squared plus beta squared plus gamma squared. Now, since you have known s minus 1, let's try using recurring method. We will try all of them for our understanding. For recurring, let's divide through by x. Let's start by dividing through by x. So we are going to have ax squared plus bx plus c plus d over x equals 0. You can see the pattern we have now. Since this is 0, we have no problem. Now, once we have done this, let us substitute into each. Let's substitute the 3 roots into the equation. We can do it straight if you have known it already, but I'm using this one as example. So this one will be a alpha squared plus b alpha plus c plus d over alpha. A beta squared plus b beta plus c plus d over beta. The third one will be a gamma squared plus b gamma plus c plus d over gamma equals 0. Now, let's sum the 3. These 3. We are going to have a s2, you can see, plus b s1 plus 3c plus d s minus 1 equals plus d s minus 1, yes, equals 0. We know what our s1, s minus 1, we know what they are. Now let's substitute. Let's divide through by a first. We are going to have s2 plus b over a s1 plus 3c over a plus d over a s minus 1 equals 0. Now, what is our s1? Our s1 is minus b over a. So let's start. So, s2 plus b over a into minus b over a plus 3c over a. What is our s minus 1 now? D over a minus c over d. Minus c over d equals 0. So that's going to be very interesting now. So we are going to have this one cancel this. So we are now going to have s2 minus b over a squared. Can see? This one and this one are the same. So plus 2c over a equals 0. So we can now get our s2 now. S2 is equal to b over a squared minus 2c over a. What is our b over a? That is sum. So S2 is equal to summation alpha all squared. What is our c over a? That is sum of pairs of the roots. This one over a. Sum of pair of the roots. Minus 2 summation alpha beta. You can see, because we have known this one, s minus 1, that's why we can do recurring now. Let us now use full expansion, multiplication and expansion, and then of the roots, full multiplication and expansion of the roots. Now let's look at it in another way. We have s2 to be equal to alpha squared plus beta squared plus gamma squared. Looking at this, from what I have before, I cannot factorize this and get any meaning out of it. So the only thing I can do is to square some of the roots. And how do I mean? Look at this. Alpha, beta, gamma. Alpha, beta, gamma. So if I have it like this, then I'm going to have alpha squared, alpha beta, alpha gamma. Alpha beta, beta squared, beta gamma. Alpha gamma, beta gamma, gamma squared. So let's bring out this expression now. Therefore, alpha plus beta plus gamma all squared will be equal to alpha squared plus beta squared plus gamma squared. You can see this one. So this one and this one is going to give me 2 alpha beta plus 2 alpha beta plus this one and this one is going to give me alpha gamma, 2 alpha gamma, 2 alpha gamma, and this one is going to give me 2 beta gamma. You can see. So from this, it is even easier to extract the value. So I can now say that alpha squared plus beta squared plus gamma squared is equal to alpha plus beta plus gamma all squared minus 2 into alpha beta plus alpha gamma plus beta gamma, which is equal to summation alpha all squared minus 2 summation alpha beta. You can see, same thing is what we got the other time. I am doing this so that you will find it as fun to use any of them, any of the techniques. The expansion, that is using the sum of roots and other expressions, or recording, or substitution. Let's see what we can do with substitution too. So what this means is this. From this, if you had known this one, we can easily get S1 if you have not gotten S1. So it depends on you. Whatever the situation that arises, observe and tackle, develop your strategy and tackle it. Let's go to the next question. Now we have to find S3. That is alpha q plus beta q plus gamma q. Fortunately, we know our S2 now. We know our S1. Then we can use the recurrence method. Now let's try with recurrence now. I can now say A alpha q plus B alpha squared plus C alpha plus D equals 0. A beta q plus B beta squared plus C beta plus D equals 0. A gamma q plus B gamma squared plus C gamma plus D equals 0. So what do we have now? We have A S3 plus B S2 plus C S1 plus 3D equals 0. Please, I want to take notes. Maybe I've said it before. By the time you get all this, you can get this one without going through this step. The only thing that changes is the constant that will be multiplied by the degree. That's all. Look at every other thing. Coefficients remain the same. It's only the constant that's affected. Go and check the previous ones we did. And in the subsequent ones we do, observe please. So if you know these things, it will reduce your time of working these things out. Now, you can find our S3 now. You can say, let's divide by A. So S3 plus B over A S2 plus C over A S1 plus 3D over A equals 0. Now, so let's shift these ones to the other side. So we now have S3 to be equal to minus B over A S2 minus C over A S1 minus 3D over A. What is our minus B over A? That is sum. That is sum of the roots. And S2, we know what our S2 is. So we are going to have summation alpha into summation alpha all squared minus 2 summation alpha beta. You get this one? That is for this first one. The next one, what is our S1? That is summation alpha. What is our C over A? That is summation of the pairs of the. So we have this one. Minus. What is C over A? Summation alpha beta. And what is S1? Summation alpha. You have gotten that one. What is, so we have minus 3. What is our D over A? That is minus the product. That is times minus alpha beta gamma. So please, I want you to observe clearly. Now let me expand it. Looking at this one times this one is going to give me summation alpha cube. Please take notes. This one and this one is going to be 2 minus 2 summation alpha beta minus 2 summation alpha beta. This one again is minus summation alpha beta. Take note please. Minus summation alpha beta. So I have two with this ones. So minus times minus is plus. So plus 3 summation alpha, beta, gamma. You can see. So at the end of the day, I'm going to have summation alpha all cube minus 3 summation alpha beta plus 3 summation alpha beta gamma. So that is if we use recurrence. If we now use pure expansion, let's see what it will look like. So it depends. So please practice this by yourself in this algebraic form. It's fun. So when you come across the real question, you find it very easy. Let's work it out from the cube. That is alpha plus beta plus gamma cube, which will be alpha plus beta plus gamma squared into alpha plus beta plus gamma. We have gotten this one where we are doing that of squares. So let's work it out. Alpha plus beta plus gamma here. So we are going to have it like this. Alpha, beta, gamma. Okay, squared. That is alpha beta squared. So we have alpha squared, beta squared, gamma squared, and 2 into alpha beta plus alpha gamma plus beta gamma. We have this one here. And here too, we are going to have alpha, beta, and gamma. Now, on expanding this, I'm going to have alpha cube, alpha beta squared, alpha gamma squared, and this one will be 2 alpha into alpha beta plus alpha gamma plus beta gamma. This one is going to give me alpha squared beta, beta cube, beta gamma squared, 2 beta into alpha beta plus alpha gamma plus beta gamma. This one will be alpha squared gamma, beta squared gamma, gamma cube. And this one will now be 2 gamma into alpha beta plus alpha gamma plus beta gamma. You can see. Now, let me write out the expression. So this will now give us alpha cube plus beta cube plus gamma cube. Looking at this, so I'm going to have 2 into alpha plus beta plus gamma into alpha beta plus alpha gamma plus beta gamma. So I got all these ones. So it remains this part. So I have alpha squared plus alpha squared alpha beta. Okay, let's make it alpha beta into alpha plus beta. Please take note, these two. Alpha beta into alpha plus beta plus alpha gamma into alpha plus gamma. This one and this one. So I have this one remaining plus beta gamma, this one, into beta plus gamma. Please take note of how I arrange it. Then, by the time I gather this one, I want to make something. I make this up so that I be able to extract the sum equal to alpha cube plus beta cube plus gamma cube plus 2 into alpha plus beta plus gamma into alpha beta plus alpha gamma plus beta gamma plus, I want to make this up so that I be able to extract the sum. Look at what I'm going to do. Alpha beta into alpha plus beta plus gamma minus gamma. Please take note of that. I do it plus alpha gamma into alpha plus gamma plus beta minus beta. And this one plus beta gamma into beta plus gamma plus alpha minus alpha. You see what I'm going to do now? Now, so this will now be equal to alpha cube plus beta cube plus gamma q plus 2 into alpha plus beta plus gamma into alpha beta plus alpha gamma plus beta gamma into plus alpha beta into alpha plus beta plus gamma minus alpha beta gamma. That's what I want to achieve there. Here again, plus alpha gamma into alpha plus beta plus gamma minus alpha beta gamma. And here too, plus beta gamma into alpha plus beta plus gamma minus alpha beta gamma. So at the end of the day, this one is going to be gamma q plus beta q. So sorry, alpha q plus beta q plus gamma q. Let's add this one. This one now, I have alpha beta gamma. This is another factor here. So this one, I'm going to have plus 2 into alpha plus beta plus gamma into alpha beta plus alpha gamma plus beta gamma. You can see that. And this one is common to this one. 1, 2, 3. Now, so this gives me this. You can see this is common to the three of them. So I have alpha plus beta plus gamma into alpha beta plus alpha gamma plus gamma beta. This one minus 3 into this alpha beta gamma. Please, I believe I have done justice to this. So this is the expansion for the cube. So at the end of the day, I'm going to have alpha q plus beta q plus gamma q plus 3, this one and this one, into alpha plus beta plus gamma into alpha beta plus alpha gamma plus beta gamma minus 3 alpha beta gamma. You can see. So this is the expansion for this one now. That is alpha plus beta plus gamma all q will be equal to alpha q plus beta q plus gamma q plus 3 into alpha plus beta plus gamma into alpha beta plus alpha gamma plus beta gamma minus 3 alpha beta gamma. You can see that's the expansion. Now this is what I've been trying to get. Alpha q plus beta q plus gamma q. Therefore, alpha q plus beta q plus gamma q is equal to alpha plus beta plus gamma all q. You can see minus 3 into alpha plus beta plus gamma into alpha beta plus alpha gamma plus beta gamma plus 3 alpha beta gamma. So we can now represent it as summation alpha all q minus 3 summation alpha beta. You can see. And this one plus 3 summation alpha beta gamma. So we have done this. We have done that of the cube already now. So you can see you can achieve our answers in different ways depending on the one that is convenient for you. But I'd rather you learn this by heart, the derivatives by heart. Now we have a question. S3 plus 2x plus 5 equals to 0. Alpha, beta, and gamma are the roots. Find S1, S minus 1, S2, S3, S minus 3. In this situation, any method that comes to us that I feel like let's try to use it. But I will try to use two methods where possible, so that will be point of learning. Now we know that our S1 is equal to minus B over A. And in this instance, our A equals 1, our B equals 2, our C equals 0, and our D equals 5. Therefore, S1 will be equal to minus 2 over 1. S1 is minus 2. So let me write it. And we have S minus 1 S minus 1 is equal to 1 over alpha plus 1 over beta plus 1 over gamma, which is beta gamma plus alpha beta over alpha beta gamma, and that is summation of alpha beta over summation of alpha beta gamma. We knew this to be C over A over minus B over A. What is our C? Our C is 0. So S minus 1 is equal to 0. So S is equal to 0. Now, we also asked S2. S2. How do we find S2? We know our S2 to be summation alpha all squared minus 2 summation alpha beta. And what is this one? S1 is equal to minus 2. Minus 2. What is summation alpha beta? That is C over A. So this is equal to 4. So our S2 is 4. We can also do it in this way. Let's divide this equation through by x. So we have x squared plus 2x plus 5 over x equals 0. So in this instance, we are trying to use recurring method. Recurring. So what do? Put alpha, beta, and gamma into the equation. So we have alpha squared plus 2 alpha plus 5 over alpha is equal to 0. Beta squared plus 2 beta plus 5 over beta equals 0. Gamma squared plus 2 gamma plus 5 over gamma equals 0. Now, with this, what is our so we have S2 plus 2S1 plus 5S minus 1 is equal to 0. S2 plus 2. What is our S1? Our S1 is minus 2. What is our S minus 1? Our S minus 1 is 0. So which means that S2 minus 4 is equal to 0. S2 is equal to 4. So you can see the two ways that we use to get our S2 now. We have used recurring, we have used what's it called? The outright formula. We have used that one, calculation. So we can also use substitution. But I don't want to go into that. You can try that by yourself. So S2 is equal to 4. Now let's try S3 and S minus 3. Now let's look at this. For S3, we know that one to be all cube minus 3 summation alpha to summation alpha beta plus 3 summation alpha beta gamma. And this one, you know this one to be B over A, that is minus 2 all cube. That is it. Minus 3. What is this one? Minus 2. What is this one? Alpha beta. That is C over A, that is 0. Plus 3. And what is this one? That is minus G over A. What is our G? That is 5. So, into minus 5. And that is minus 8, minus 15, minus 23. Our S3 is minus 23. So, another way we can look at it is recurring method. If you do that recurring method, what you are going to have is S3 plus 2S2 plus 15 equals 0. That is 3 times 5. S3 plus 2S2 plus 3 times 5 equals 0. I want to show you that this one times the degree. That is why we have this. So we are going to have S3. What is our S2? Our S2 is 4 times 2, 8 plus 15 equals 0. So S3 is equal to minus 8 minus 15 minus 23. So you can see, we also got it through recurring method. So let me register it here. S3 is equal to minus 15. So we got it through our calculation from the sum and the products. And we also got it from the recurring technique. This is recurring. Please take notes. From the recurring technique. So we got it that way. You can also try substitution. And if you want to do substitution, you just be careful on what you are putting in each part, because you just be expanding over and over again. Now let's do the third one. I mean the last one. Let's do the last one. Now the easiest way to get s3 is by recurring method for s3. So let's divide 2 by x cubed. So we have this one to be 1 plus 2 over x plus 5 over x cubed equals 0. Plus 2 s minus 1 plus 5 s minus 3 is equal to 0. And you know that we are trying to find s minus 3. We know this one to be 3. What is our s minus 1? 0. So this one is going to be 3 plus 2 into 0 plus 5 s minus 3 is equal to 0. Therefore, 5 s minus 3 is equal to minus 3. So s minus 3 is equal to minus 3 over 5. So that is the sum of the cube of the reciprocal. That is what it means. That is summation 1 over alpha cube. Now look at this. We have the equation 3x cubed plus 2x squared minus 4x plus 1 equals 0. Find s3. You can easily find all these values, either s1, s2, s3, whatever. If you want to find it, what is our a? 3, b 2, c minus 4, d 1. From the formula straight, we can do something like this. S3 summation alpha cube minus 3 summation alpha beta plus 3 summation alpha beta gamma. Now, what is this one? Minus b over a cube minus 3 into minus b over a. What is alpha beta? That is c over a. And this one, minus d over a. That is if you use the formula straight. And what is it going to be? Minus, what is b? 2. Minus 2 over 3 cube minus 3 into minus 2 over 3. What is c over a? Minus 4 over 3 plus 3. What is our d? 1. So minus 1 over 3. You can see. Minus 1 over 3. So let's get it out. We are having minus 8 over 27. This one called this. So I have minus 8 over 3 minus 1. So the LCM is 27 now. Minus 8. 9 times 8, 72. Minus 72. Minus 27. So this is minus 107 over 27. Minus 107 over 27. We can also use the recurring method. So in this instance, the whole thing is going to be 3s3 plus 2s2 minus 4s1 plus 3 equals 0. Now let's find out what our s1 is. Our s1 is minus b over a minus 2 over 3. Our s2, we can easily find that. Our s2 will be equal to summation alpha minus 2 summation alpha beta. Sorry, summation alpha squared. Our s2 is summation alpha squared minus 2 summation alpha beta. So what is our alpha? That is minus 2 over 3 all squared. What is our alpha beta? That is c over a. That is 2 times minus 4 over 3. That is so this is going to give me 4 over 9. This one is 8 over 3 plus 8 over 3, 9. This is 24, 28 over 9. So let me now slot in these values here. So I have 3 s3 plus 2. What is my s2? 28 over 9. What is my s1? Minus 2 over 3 plus 3 equals 0. Now from above, we realize that 3s3 plus 2s2 minus 4s1 plus 3 equals 0. So 3s3 plus 2. What is our s2? 28 over 9 minus 4. What is our S1? Minus 2 over 3 plus 3 equals 0. So we have 3s3 plus 56 over 9 plus 8 over 3 plus 3 equals 0. 3s3 plus 56 plus 24 plus 27 over 9 equals 0. So all these ones will give us 80, 107. So 3s3 plus 107 over 9 equals 0. So s3 is equal to 107 divided by 9 times 3, which is 107 over 27. So just like before, we got 107 over 27. The only thing is that this recurring method, you need to know the values one by one like this for s1, s2 sometimes. But for the straight formula, all you need to do is to pick your values from the coefficients and get it straight. Observation and work out, strategize and work out from the best angle. Now look at this. We have s3 minus 3s plus 4 equals 0. Find the value of s minus 3. Just like the other one we did, you can just divide 2 by x cubed. So divide 2 divided by x cubed. So we have 1 minus 3 over x. Now on applying the recurring method, this will become 3 minus 3s minus 1 plus 4s minus 3 equals 0. Now what is our s minus 1? So we get that one. Summation alpha beta over summation alpha beta gamma. And what does that give us? What is our alpha beta? That is c over a. And this one is minus d over a. What is our c here? Our c is 0. So this is 0 automatically. Therefore, 3 minus 3 into 0 plus 4s minus 3 is equal to 0. Please, I hope you understand this one. In this instance, our a is 1, b is minus 3, c is 0, and d is 4. So, 4s minus 3 is equal to minus 3. So, s minus 3 is equal to minus 3 over 4. So, very easy and straightforward. That's the cheapest way to get the answer by recurring method. Now, let's undo quadratics. Quadratics are polynomials of degree 4. And they are always in this format: ax plus bx cubed plus cx squared plus dx plus e equals 0. We always have it in this format. And for ease, when we are trying to get the roots, we always make the coefficient of x raised to the power 4 1. So we always make it like this: x raised to the power 4 plus b over a x cubed plus c over a x squared plus d over a x plus e over a equals 0. Now that we have it like this, it is expected that it will have 4 roots. So let's make the roots alpha, beta, gamma, and delta. So the factors will be x minus alpha, x minus beta, x minus gamma, and x minus delta. What this means is the product of these 4 will give us this expression here. So that is x minus alpha times x minus beta times x minus gamma times x minus delta will be equal to x raised to the power 4 plus b over a x cubed plus c over a x squared plus d over ax plus e over a. That is what we expect. And from our last work in cubics, we have known the expansion of this. So we will use the way we have been using to equate these two, so that we can get the relationship that the coefficients have with the roots. So we know that this one is now. So let's have it straight. Let's start. So we know that this one is x cubed minus alpha plus beta plus gamma x squared plus alpha beta plus alpha gamma plus beta gamma x. Please, I hope you are following. So the other one now will be minus alpha beta gamma. And this one we have here. We are going to have x minus delta. Now let's expand space. We are going to have x raised to the power 4 minus delta x cubed. This one will be minus alpha plus beta plus gamma x cubed. This one will be plus now. So we are going to have alpha delta plus beta delta plus gamma delta x squared. We are going to have alpha beta plus alpha delta alpha gamma plus beta gamma x squared. That's what we have here. And here now, we are going to have minus alpha beta delta plus. No. We are going to have it like this. Minus, because of this negative here, minus alpha beta delta plus alpha gamma delta plus beta gamma delta x. Now, this one will now be alpha beta gamma x. Please, that's what that one will be. This one here will now be positive gamma beta alpha. This one will be alpha beta gamma delta. Now let's work out what the total expansion will be now. The expansion will now be, that is, the product, this product will now be x raised to the power 4. This one and this one, they have the same, they are the same terms. So minus alpha plus beta plus gamma plus delta x cubed. This one and this one, they are the same. They are coefficients of x squared. So I'm going to have plus alpha beta, alpha delta, alpha gamma, alpha delta. You can see. So I have alpha beta plus alpha gamma plus alpha delta. You can see. You can see this one. Beta delta plus beta gamma plus beta delta. This is beta delta plus gamma delta. All these ones are x squared for x squared. Now look at this one. They are the same terms. So that will be minus now. Minus alpha beta delta, alpha gamma delta, alpha beta gamma, then beta gamma delta. So let's go on. Alpha beta delta plus alpha gamma delta plus alpha beta gamma plus beta gamma delta x plus alpha beta gamma delta. You can see this expansion, we will equate it to this one so that we can compare the coefficients. Please, because of space, I want you to look at this one and this one. Please look at them. Look at the coefficient of x cubed. What is the coefficient of x cubed? B over A is equal to minus alpha plus beta plus gamma plus delta. What does that mean? It implies that, you can see, what does that imply? It means that the sum of the roots, alpha beta plus gamma plus delta, is equal to minus b over a. Please keep those things. These are very important for future work. So look at it. C over a is sum of the roots in pairs. So C over a. Again, before I go on, please, that b over a, we also write it as alpha, summation alpha. Please take notes. And invariably, it is also S1. Please take notes before I go on to the next one. Now, the next one is this. This is the next one. That is C over A is equal to alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. You can see that is the sum of the roots in pairs. 2, 3, 4, 5, 6. So we can also write it as summation alpha beta. Please take note. C over A, this one is positive. That is it. Straight. Take note this. Now let's look again for the x. Look at the coefficient of x. That is d over a is equal to minus the sum of the root in triples. So alpha, beta, delta. So what does that imply? It means that minus d over a is equal to alpha, beta, delta plus alpha, gamma, delta plus alpha, beta, gamma plus beta, gamma, delta. So we can also write it as this: alpha, beta, gamma. That is in threes, the sum of the root in threes. That is what it means. You know, combination, if you do combination, you know that it is 4, 6, 3. Now look at it. You have done D. Now for the last one, you see, the last one is E over A is equal to alpha, beta, gamma, delta. Straight. So you can also write it as this: alpha, beta, gamma, delta. So you can see. So, and from our previous observation, you can see positive, negative, positive, positive, negative, positive, negative, positive. That is the sequence. So since you have gotten this, we can also do some other work from this place now. Now we can say conveniently that minus b over a is, if you can also refer to as S1, c over a is sum in pairs, minus d over a is sum in threes, and e over a is the product of all of them, sum in 4. So that is it. Now let's quickly work this out. We have this equation here, quadratic, and we have to find expression for S1, S minus 1, and S2. So for our previous work, we know that S1 is equal to minus b over a. Now for S minus 1, will be equal to 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta. And LCM will be alpha, beta, gamma, delta. So here we are going to have beta, gamma, delta plus alpha, gamma, delta plus alpha, beta, delta plus alpha, beta, gamma. And from our work, we know what will be the sum in threes. That is, the numerator is minus d over a, and the denominator is e over a. So at the end of the day, we are going to have minus d over e. So you can leave, this is the easiest, or the best thing is to say summation alpha, beta, gamma over summation alpha, beta, gamma, delta. So this is the most convenient way to express it, and this is the conventional way of expressing it. Now we have to find S2. Now I want to find S2, which is alpha squared plus beta squared plus gamma squared plus delta squared. From the expressions we have had, using the coefficients of the x and the constants, we cannot bring this out easily. So the way out is to multiply the sum twice. And let's use the table to make it easy for us. Alpha, beta, gamma, delta. Alpha, beta, gamma, delta. So we have alpha squared, alpha, beta, alpha, gamma, alpha, delta. Alpha, gamma, alpha, delta. Here we have alpha, beta, beta squared, beta, gamma, beta, delta. Alpha, gamma, beta, gamma, beta, and gamma squared, gamma, delta. Here we have alpha, delta, beta, delta, gamma, delta, delta squared. So writing this out is going to give me, that is, alpha plus beta plus gamma plus delta will give me, will give me alpha squared alpha squared plus beta squared plus gamma squared plus delta squared. This one. Now, this one and this one is going to give me 2 alpha beta. This one and this one is going to give me 2 alpha delta. Alpha gamma. Sorry. This one and this one gives me 2 alpha gamma. This one and this one give me 2 alpha delta. You can see. Now, this one and this one give me 2 beta gamma. You can see. This one and this one give me 2 beta delta. You can see. This one and this one gives me 2 gamma delta. You can see. So at the end of the day, I have summation alpha squared, this one, please, plus 2 summation alpha beta, this ones. Can you see? These ones, all of them, that is in pairs. I don't want to waste time on it. So, now, you can see it from here now, that this is summation alpha all squared is equal to summation alpha squared plus 2 summation alpha beta. You can get that. And we now know that S2, which is summation alpha all squared, is equal to summation alpha all squared minus 2 summation alpha beta. And we know what this one is. It's minus b over a all squared minus 2 into c over a. So please, just learn it by this. You know how to get that one conveniently. So this is the way out. So we have gotten our S1, S minus 1, and S2. Now look at this expression. X equals 4 plus 3x squared minus x plus 5 equals 0. Find S2 and S4. From this, we can find S2 using the formula now. You know that S2 is equal to summation alpha all squared minus 2 summation alpha beta. Let's write out the coefficients. Our A equals 1, B equals 0, C equals 3, D equals minus 1, and E equals 5. So, we know our summation alpha to be equal to minus B over A, which is 0. And our summation alpha beta is equal to C over A, that is 3. So, S2 will be equal to 0 squared minus 2 times 3, which is minus 6. So that's our S2. We have gotten our S2 now. But we have to find S4. S2 minus 6. We can use the recurring method now, since we know this one, to find S4. We don't have any time in x cubed, so it's very easy for us to use the recurring method. Let's do that. Then, let's quickly do this. By the time we have all this summed out, we are going to have S4 plus 3S2 minus S1 plus 5 times 4 equals 0. And you're going to write it out like this. I've said it. Whenever you have constants, no matter what, it will be multiplied by the degree. So we now have S4 plus 3S2 minus S1 plus 20 equals 0. From our observation, our S1 is equal to 0 because B is 0. That is minus B over A, and B is 0. That is the coefficient of x cubed. Now let's quickly work this out. What's our S2? We got down to minus 6. Therefore, S4 plus 3 into minus 6 minus 0 plus 20 equals 0. You can see. Therefore, we can now see S4, this is 18 plus, that is 2, is equal to 0. Therefore, S4 equals to minus 2. So, this is S2. S4 equals minus 2. So, we've gotten that. Now, let's use substitution method. Let's see how it goes. Since we are going to have S2 and S4, so let's work it out like this. Let y be equal to x squared. Therefore, x will be equal to root of y. So substitute root of y for x in the equation. So what are we going to have? This one is going to be root of y raised to the power 4 plus 3 into root of y all squared minus root of y plus 5 equals 0. It's easy now because I don't have any term in Q. That's why I can do this one conveniently, please. So this one now is going to be y squared plus 3y minus root y plus 5 equals 0. Therefore, I have y squared plus 3y plus 5 equals to root y. Square both sides. Square both sides. What do I have? I make the table and then I multiply it out. Don't let me waste your time with that. So, on squaring both sides, this is what I got. Therefore, y raised to the power 4 plus 6y cubed plus 19y squared plus 29y plus 25 equals 0. So, please note, in this instance, s1y is equal to s2x. This is our original equation, and that's where our answer is going to. Now, if you look at this, s1y is equal to minus b over a. In this instance, minus b, let me put it, dy, what will that be? Minus 6 over 1, which is minus 6, and which is s2x. So you can see, it's the same thing. Now, let's find our s4 from this. So, s4 for x is equal to s2 in y. Just showing you how to go about it. And how do we get that? We got that one, that's s2y will be equal to summation alpha in y all squared. Please, I just put it that subscript y so that you will flow. Minus alpha, 2 alpha, summation alpha, beta, y. What is this one? We have gotten it, minus 6 squared. What is this one? Minus 2. What is alpha b, y? That is 19 over 1 times 19. And this is going to be 36 minus 38, which is equal to minus 2. So you can see, we got the same answer using the same technique. So I'm just showing you as examples of using all of them. Recurring, substitution, and working from the sum and product of the roots. Now we have this expression, x raised to the power 4 minus x squared plus 2x squared minus 2x minus 5 equals 0. Find s minus 1 and s2. So this one can be easily gotten from the formulas. Because if we are trying to do substitution, or it will take unnecessarily long time. So let's also find it. S minus 1 is equal to summation alpha beta gamma over summation alpha beta gamma delta. And from our knowledge, we know that this one is E over A, and this one is minus D over A. And what does that give us? This one is 2, and this one is minus 5. So this is minus 2 over 5. Minus 2 over 5. And our S2 is equal to summation alpha all squared minus 2 summation alpha beta. You can see, what is our summation alpha all squared? That is minus 1 squared. That is minus b over a all squared. That is this one. Minus 2. What is summation alpha beta? That is c over a. That is into c over a. This one, our b is minus 1. So, minus 1 over 1. That is, this is minus 1. b is minus 1. Minus 1 times minus, that is 1. Over 1, 1. So, we have 1 all squared. Minus 2 times, what is our c? Our c is 2 over 1. That is it. And this is 1 minus 4. And that is minus 3. So, you can see, very easy when you know the formula. But sometimes the formula might not be totally okay. But it's very good to start by knowing the formulas. Thank you very much for your patience. And I implore you to practice and work this one alone. It's always good when you come for this with your pen and paper. Thank you very much. Those who have subscribed, we appreciate. Those who comment, those who like, and those who also share, I appreciate everything. Those who haven't, please kindly do that. Also, your comments, corrections, they are our source of inspiration and encouragement. We appreciate you all. Thank you very much.